Imagine a world where every time you tried to measure something, you got a different answer. Sounds crazy, right? But that's exactly what life was like before the Royal Society and the invention of the decimal system. In the 17th century, people in Britain and other parts of Europe were struggling with a big problem. Their words and measurements were all over the place. This chaos was not just annoying, it was holding back progress in science and technology. That's when a group of brilliant minds decided to change everything. The Royal Society was founded in 1660 with a clear mission: to make knowledge as simple and precise as possible. Bishop Sprat, one of its early supporters, summed it up perfectly: not the artifice of words, but a bare knowledge of things. At that time, the Puritans were known for their long, flowery sermons and parliamentary speeches, which many thought were causing more trouble than good. Their verbose style was seen as a threat to peace and good manners. So, the Royal Society set out to reform the way people spoke and wrote, aiming for a clear, straightforward, and natural way of communication. To achieve this, the Society insisted that its members use a close, naked, natural way of speaking. They wanted positive expressions, clear meanings, and a native ease in language. They believed that bringing everything as close to mathematical plainness as possible would help in understanding and advancing knowledge. They even preferred the language of artisans, countrymen, and merchants over that of scholars and wits. The idea was to make communication as simple and universal as possible, so that everyone could understand and contribute to scientific knowledge. But it wasn't just about the words. The Royal Society also wanted to make sure that scientific experiments were precise and repeatable. They insisted that experiments be performed by their members whenever possible, and that the results be verified through direct observation. This was a significant shift from the past, where naturalists often collected random and sometimes misleading information. By making experiments repeatable, they could coordinate and confirm findings, gradually building a reliable body of knowledge. One of the biggest challenges they faced was the lack of a universal language of measurement. Different countries, and even different regions within the same country, used different units of measurement. This made it difficult for scientists to compare and confirm each other's findings. For example, in England, the early Tudors had established a furlong as 220 yards, and Queen Elizabeth I later decreed that a mile should be 5,280 feet, making it easier to use. But even then, there were still many different units of weight and capacity, causing daily inconvenience and opportunities for fraud. In Europe, the situation was even more chaotic. A dictionary of local units of weights and measures used in France before the Revolution is a staggering 200 pages long. Every trade had its own vocabulary, and the variety of units made it nearly impossible to standardize measurements. This is where Simon Stevin, a Belgian tradesman, came to the rescue. Despite not entering the University of Leiden until his mid-30s, Stevin became a celebrated figure in his lifetime. His most significant contribution was the decimal system, which he introduced in a 36-page booklet called The Tenth in 1585. Stevin's decimal system was revolutionary because it simplified the way fractions were handled. Instead of dealing with cumbersome fractions, he proposed treating all fractional units as integers. For example, the quantity 4 and 29/100 could be treated as 429 items of the unit 1/100. This made it easier for experimenters to deal with whole numbers and simplified calculations for merchants, bankers, and scientists. Stevin's system could be used for weights, measures, coinage, and even divisions of time and degrees of the arc of a circle. Stevin's idea was so simple yet powerful that it quickly gained traction. John Napier, a Scottish mathematician, further refined the system by introducing the decimal point, making it even more user-friendly. The decimal system soon became a cornerstone of modern mathematics and science, enabling precise and consistent measurements across different fields. Another key figure in the quest for standardization was Gabriel Mouton, a priest in Lyons, France. Mouton was fascinated by the idea of a universal unit of measurement based on the pendulum. He discovered that the length of a pendulum with a frequency of 1 beat per second varied with latitude. This led him to suggest that these variations could be used to calculate the length of a degree of the terrestrial meridian. This idea was later picked up by the French Academy, which proposed a new unit of length based on the Earth's meridian. This unit, known as the meter, would be 1/10,000,000th of the length of a quadrant of the Earth's meridian. The French Academy's proposal was ambitious, and they sought the cooperation of the British Royal Society to make it a reality. However, the British never joined the effort, so the French went ahead on their own. They defined the meter as the length of a pendulum that beats once per second at 45 degrees latitude, and from this, they derived all other metric units. A cube 1 meter on each side would be the measure of capacity, and the cube filled with water would be the unit of mass. This system, based on natural constants and the decimal system, became the foundation of the metric system we use today. In the United States, Thomas Jefferson was also a strong advocate for standardization. The federal Constitution gave Congress the power to fix standards of weights and measures, and Jefferson worked tirelessly to create a uniform system. He proposed a pendulum-based system similar to Mouton's, but he also recognized the importance of a decimal monetary system. Jefferson's efforts were part of a broader movement to use science and technology to unify and advance society. The development of precise scientific instruments was another crucial factor in the advancement of science. In the 17th and 18th centuries, countries like Britain, France, the Netherlands, Germany, and Italy became leaders in both scientific theory and instrument making. These instruments transformed the old Aristotelian world of qualities into a new Baconian world of quantities. Scientists like Galileo and Newton relied on precise measurements to test their theories, and the instruments of measurement became essential tools in the scientific community. One of the most significant improvements in measurement instruments was the vernier, invented by Pierre Vernier, a French military engineer. The vernier was a simple yet powerful device that improved the accuracy of measurements. It was an improvement on the nonius, a device developed by the Portuguese mathematician Pedro Nunes. The nonius used concentric circles to measure fractions of a degree, but it was not precise enough for some applications. Vernier's innovation was to replace the static concentric circles with a mobile segment that could be rotated to find a precise match with the line of sight. This made it easier to measure fractions of a degree with great accuracy. The vernier was quickly adapted to various instruments, including calipers and other measuring tools, and it revolutionized the fields of surveying and navigation. The ability to measure small angles and distances with precision was crucial for the development of modern science and technology. In conclusion, the efforts of the Royal Society, Simon Stevin, Gabriel Mouton, Thomas Jefferson, and many others were instrumental in creating a world where knowledge is precise, measurable, and universal. The decimal system and the metric system, along with the development of precise scientific instruments, have made it possible for scientists around the world to work together and build on each other's discoveries. The quest for standardization has not only advanced science, but has also made our daily lives easier and more consistent. Whether we're baking a cake, building a house, or exploring the universe, we can thank these pioneers for making it all possible.